Hi, I'm Bob. Welcome back to the tutorial on the exercises from the textbook Microeconomics Theory and Applications with Calculus, the 5th edition. We will start to solve the exercises in Chapter 13, Game Theory. Here's exercise 1.1. Show the payoff matrix and explain the reasoning in the prisoner's dilemma example where Larry and Duncan, possible criminals, will get 1 year in prison if neither talks. If one talks, one goes free and the other gets 5 years. And if both talk, both get 2 years. The payoff matrix is the normal form representation of a static game of complete information, such as the prisoner's dilemma. The payoff matrix shows the payoffs for each of the 4 possible combinations of the strategies that Larry and Duncan may choose. The payoffs are negative because they represent years in jail, which is bad. In each cell, the first number is Larry's payoff, and the second number is Duncan's payoff. We use the best response approach, and we'll see that convex is the dominant strategy of both players. If Duncan chooses to convex, Larry gets 2 years in prison if he chooses to confess, but gets 5 years in jail if he decides to be silent. His best response is to convex. We underline his payoff -2. If Duncan chooses not to confess, Larry goes free if he talks and gets 1 year in prison if he remains silent. He is better off confessing. We underline the number 0. Confess is Larry's dominant strategy because it produces a higher payoff regardless of his rival's strategies. By the same type of reasoning, convex is also Duncan's dominant strategy. If Larry confesses, Duncan gets 2 years in prison if he chooses to confess, but gets 5 years in jail if he remains silent. We underline his payoff -2. If Larry does not confess, Duncan gets free if confessing, but 1 year in prison if not. His best response is confessing. We underline the payoff of 0. Duncan is also better off confessing no matter what his rival chooses. We then circle the cell with both payoffs underlined. It is the outcome of the Nash equilibrium of the game. Both players confess and get 2 years in jail. Let's try exercise 1.2. Show that advertising is a dominant strategy for both firms in both panels of table 13.3. Explain why that pair of strategies is a Nash equilibrium. As the payoff matrix shows, in each cell, the first number is firm 2's payoff, and the second number is firm 1's payoff. We use the best response approach, and we'll see that advertising is a dominant strategy for both firms. We first find firm 1's choice. Suppose firm 2 chooses not to advertise. Firm 1's best option is to advertise because it makes a profit of 3 if it decides to advertise, instead of 2 if it does not. We underline the number 3. Suppose firm 2 chooses to advertise. Firm 1's best response is still to advertise because it brings a profit of 1 instead of 0. We underline the firm 1's payoff 1. You see that to advertise is firm 1's dominant strategy because it is its best response regardless of firm 2's choices. The same reasoning applies to firm 2. If firm 1 chooses not to advertise, then firm 2 gets a profit of 2 if it follows suit. However, it gets 3 if it advertises. Firm 2 will advertise in this case, and we underline the number 3. If firm 1 chooses to advertise, firm 2 gets 0 if not advertising, but 1 if advertising. Advertising is its best response. We highlight the number 1. We then circle the cell with both payoffs underlined. That is the outcome of the Nash equilibrium of the game. The Nash equilibrium is that both players choose to advertise. It is a Nash equilibrium because no player wants to deviate from it. Similarly, in panel B, we can show that advertising is a dominant strategy for both firms. The Nash equilibrium is that both players choose to advertise. The outcome is that each player gets a profit of 5. Let's solve exercise 1.3. Two firms must simultaneously decide which quality to manufacture. The profit matrix is as follows. Identify all the Nash equilibria in this game. As usual, we use the best response approach to find the Nash equilibrium. We first find firm 1's best response to firm 2's each choice. Given that firm 2 chooses low, firm 1's best response is medium because it gives firm 1 a payoff of 21, which is the highest among all its possible choices. Given that firm 2 chooses medium, firm 1's best response is low, and it produces a payoff of 25. Given that firm 2 chooses high, firm 1's best response is medium, and it brings a payoff of 26. We underline those numbers. The same reasoning applies to firm 2. If firm 1 chooses low, firm 2's best response is medium, and it brings 16. If firm 1 chooses medium, firm 2's best response is low, and it produces 19. If firm 1 chooses high, then firm 2's best response is medium, and it gives a payoff of 23. We also underline those numbers. We find two cells with both numbers underlined and circle them. Therefore, the two Nash equilibria are firm 1 chooses medium and firm 2 chooses low, and firm 1 chooses low and firm 2 chooses medium. Let's find answers to exercise 1.4. Suppose P&G and Johnson & Johnson are simultaneously considering new advertising campaigns. Each firm may choose a high, medium, or low level of advertising. What are each firm's best responses to its rivals' strategies? Does either firm have a dominant strategy? What is the Nash equilibrium in this game? We use the best response approach to find the Nash equilibrium. In the payoff matrix form, the first number in each cell is Johnson & Johnson's payoff, and the second number is P&G's payoff. We first find Johnson & Johnson's best response to P&G's possible strategies. Given that P&G chooses a high level of advertising, Johnson & Johnson gets a payoff of 1 if it chooses high, 2 if it chooses medium, and 3 if low. So it will choose a low level of advertising. We underline the number 3. Suppose that P&G chooses a medium level of advertising. Johnson & Johnson's best choice is low because it gives a payoff of 5 higher than the other choices. We underline the payoff of 5. If P&G uses a low level of advertising, then Johnson & Johnson's best response is still low. We underline the payoff of 7. Johnson & Johnson has a dominant strategy of choosing a low level of advertising. It is its best response, regardless of its rival's strategy. By the same reasoning, we can find P&G's best responses to each of its rivals' actions. If Johnson & Johnson chooses a high level of advertising, P&G's best response is to use a low level of advertising because it gives the highest payoff among its 3 choices. We underline the payoff of 3. Similarly, we find P&G's other 2 best responses and underline the payoffs. There is no dominant strategy for P&G. We circle the cell with 2 payoffs underlined. That is the Nash equilibrium's outcome. The Nash equilibrium of the game is that Johnson & Johnson chooses a low level of advertising and P&G chooses a medium level of advertising. The outcome of the Nash equilibrium is that Johnson & Johnson gets a profit of 5 and P&G receives a profit of 6. Let's go to exercise 1.5. Laurie employs Max. She wants him to work hard rather than to loaf. She considers offering him a bonus or not giving him one. All else the same, Max prefers to loaf. The payoff matrix is as follows. If they choose actions simultaneously, what are their strategies? It is a static game of complete information. In the payoff matrix, the first number is the payoff for Laurie and the second number is the payoff for Max. Laurie has 2 strategies, giving a bonus or not giving a bonus. Max has 2 strategies, working hard or loafing. We use the best response approach to find the Nash equilibrium of the game. We first figure out Laurie's best response. Given that Max chooses to work hard, Laurie gets a payoff of 1 if she offers a bonus, and a payoff of 3 if not. She's better off not offering the bonus. Her best response is not to provide the bonus. We underline the number 3. Suppose Max chooses to loaf. In this case, Laurie's best response is also not giving the bonus because it results in 0, which is better than -1. So her best response is not to provide the bonus. We see that no bonus is her dominant strategy. Next, we consider Max's best responses to Laurie's possible actions. If Laurie provides a bonus, Max's best response is to loaf, which leads to a better payoff than working hard. We underline the number of 3. If Laurie does not offer the bonus, Max's best response is still to loaf. To loaf is his dominant strategy. We underline the payoff of 0. Finally, we circle the cell with both payoffs underlined. That is the outcome of the Nash equilibrium of the game. The Nash equilibrium is that Laurie chooses not to offer a bonus and Max chooses to loaf. The outcome of the game is that Laurie gets 0 and Max gets 0 either. Thank you so much for watching this video and solving all the exercises with me today. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.